f of x equals negative 5x cubed. Now, if you are aware what that function looks like, it does something like this. So the opposite of what happens with x cubed because of the negative 5 there. So let's go ahead and do this for a. As x approaches bigger and bigger numbers, as x gets larger and larger, negative 5 times those large numbers is just more and more negative. So that one is going to approach negative infinity. All right. Now, as x gets more and more negative, then x cubed is more and more negative. And so these will approach positive values. So this will approach infinity. So the left-end behavior is positive infinity, as evidenced by this. And the right is negative infinity, as evidenced by that graph. All right, part B. Limit as x approaches infinity of 2x to the fourth. Now, for both ends of this function, no matter whether they are positive or negative, we end up with x to the fourth being a positive value. Okay, which means this is going to be positive infinity for both. And that graph will look something like this. That's really a quadratic, but it'll look similar to that. Describe the end behavior of 3x minus 1 over 2x plus 5. All right, well, we could actually apply L'Hopital's rule with our limits here, but we're not going to do that. All right, let's take the limit. Okay, I have 3x minus 1 over 2x plus 5. I'm going to divide by x on every term here. This would be the limit as x approaches infinity of 3 minus 1 over x divided by 2 minus or plus 5 over x. Because each of these terms goes to 0, this limit is 3/2. Now, you might notice those two terms would go to 0 regardless of whether x is positive or negative. So we might go ahead and just say that is for positive and negative infinity. All right, and that will work a lot of times. So we've just found both limits. At both ends of this function, it approaches 3 over 2. The end behavior of this function, 3x squared plus 2x over 4x cubed minus 5x plus 7. Okay. Let's go ahead and start with the positive infinity, and this might apply to both. 3x squared plus 2x over 4x cubed minus 5x plus 7. Now I'm going to divide by the largest exponent in the denominator. So I'm going to divide by... No, actually, I'll just do the squared. Let's do the squared. Squared. Okay. Although, I believe we could... Yes, we could definitely do that. In fact, we'll go ahead and do that. Let's make this... We're going to divide by the highest exponent in the denominator. All right, well, first is going to be 3 over x. 3 over x plus 2 over x squared. Okay, the denominator will be 4 minus 5 over x squared plus 7 over x cubed. Now, regardless of the value of x, all of these go to 0, so this is going to be equal to 0. Because that's regardless of the value of x, positive or negative, this will actually apply for both of these. Both ends approach 0.